In question 1, we have to prove the identity cot x minus tan x upon cot x plus tan x as cos of 2x. So we know that cot x can be written as cos x upon sin x. So we can just write cos x upon sin x, and tan x is equals to sin x upon cos x. So this will become sin x upon cos x. And we'll do the same with the denominator. So that will become cos x upon sin x plus sin x upon cos x. Now taking the LCM in the numerator, so the LCM will be sin cos. So we'll get sin cos in the numerator. So cos will multiply by cos, that will become cos squared, and sin will multiply by sin, that will become sin squared. And we'll do the same in the denominator. So that will become cos square plus sin square divided by sin cos. Now we can write this as cos square minus sin squared divided by sin cos, and this is being divided by cos square plus sin square upon sin cos. Bringing the multiplication sign, we'll take the reciprocal of cos square plus sin square upon sin cos, so that will become sin cos upon cos square plus sin squared. So sin cos and sin cos will cancel out. We know that cos squared plus sin squared is equals to 1. So this is the identity that we already know. And cos squared minus sin square is an identity of cos of 2x. So we have cos squared minus sin squared, which can now be written as cos of 2x. In question 2, we have to expand 3 plus 2x to the power minus 3 up to the term in x squared. So we know that the expansion for 1 plus b to the power n is given as 1 plus nc1b to the power 1 plus nc2b to the power 2. And we should already also know that nc1 is equals to n, and nc2 will be written as n into n minus 1 upon 2 factorial. Now in the question, we have 3 plus 2x to the power of minus 3. Now as we need a 1 in place of 3, so we can take 3 common out. So when we take 3 common out, we'll be writing 3 to the power minus 3 as the power is minus 3. Now this will become 1 plus 2x upon 3 to the power of minus 3. Now applying the expansion formula, we'll get 1 plus, so NC1 is n and n is minus 3. So that will become minus 3 into b, which is 2x upon 3. And NC2 is n into n minus 1. So that will become minus 3 into minus 4 upon 2 factorial. 2 factorial is 2 and b squared. So that will become 2x upon 3 whole squared. Simplifying, we'll get 1. This 3 and 3 will cancel out. So that will become 1 minus 2x. Plus this will cancel out with 4. The negative sign will also cancel out. We'll have 6 into, this will become 4x squared upon 9. And now we'll multiply this with 3 to the power of minus 3, which is 1 upon 27. So we have 1 upon 27 into 1 minus 2x plus, and we can simplify to write it as 3 times 2 and 3 times 3. So that is 8x squared upon 3. Multiplying it with 1 upon 27, the final answer will be 1 upon 27 minus 2 upon 27x plus 27 times 3 is 81. So that will become 8x squared upon 81. In question 3, we have to use a substitution u equals to e power x to solve the given equation. 4e power minus x equals to 3e power x plus 4. So we can first write the equation as 4 upon e to the power x is equals to 3 e to the power x plus 4. Now making the substitution, we'll get 4 upon u is equals to 3u plus 4. Cross multiplying, we'll get 4 is equals to 3u squared plus 4u. Bringing the 4 on the right hand side, we'll get 3u squared plus 4u minus 4 equals to 0. Now solving this equation quadratically with our calculators, the two values of u will be u is equals to 2 upon 3, and the second value of u will be is equals to minus 2. Now, as we have to find the value of x, and we already have the substitution, which is u is equals to e power x. So now we can write it as u is equals to e to the power of x. In place of u, we can write 2 upon 3 is equals to e power x. To find x, we'll introduce ln on both the sides. So we'll get ln of 2 upon 3 is equals to x ln of e. Ln of e is 1, and ln of 2 upon 3 will become So ln of 2 upon 3, that is minus 0.405. So x will be is equals to minus 0.405. And for the negative value of u, we know that if it is minus 2 is equals to e power x, there is no solution possible, as ln of a negative value is not possible. So the final answer will be x is equals to minus 0.405, correct to three significant figures. In question 4, we have to find the exact value of integral of sine and half theta with the limits half pi and 0. Now, as we have two different functions, so we will be using integration by parts. The formula for integration by parts is u dv is equals to vu minus v du. So one of the functions will take u and the other function as dv, and we use the method LATE, where L is for log function, A is algebraic, T is trigonometric, and E is exponential. And whichever function comes up first is taken as u, and the other function is taken as dv. Now, in this question, we have theta and sine of half theta. So, as this is an algebraic function, so this will be taken as u, and sine of half theta will be taken as dv. So, we know that we have u is equals to theta. So, du will be is equals to 1. And dv will be taken as sine of half theta. To get v, we will integrate sine of half theta. So the integration of sine is cos. So we'll get cos of half theta. And then we divide by the derivative of half theta. So that will be half. Dividing by half, we'll get a 2 over here. Now, once we have u, du, v, and dv, we can just substitute this into the equation. So we have vu. So that will become 2 cos half theta into theta. And the integral of sine is negative cos. So we have to put a negative sign over here as well. So this will become negative 2 theta cos of half theta minus and v du. So that will become minus 2 cos of half theta into 1. Now we will have minus 2 theta cos of half theta plus integral of cos of half theta. Integrating cos, we'll get sine. So the final answer will be minus 2 theta cos of half theta. And we already had a 2 over here. So integration of cos half theta is sine. And when we divide by half again, so this will become 4 sine of half theta. Once we have done the integration, we can now apply the limits. So the upper limit is half pi. So first substituting in place of theta, we'll substitute 1 upon 2 pi. So we'll get minus 2 into 1 upon 2 pi into cos of half pi. So that will become half into 1 upon 2 pi plus 4 sine of half pi. So that will become 4 sine of half. Okay, so in place of theta, this was sine of half theta. So that will become half into theta is 1 upon 2 pi. Now this 2 and 2 will cancel out, and substituting 0 in the equation we'll have, so this will become 0, as 2 times 0 will be 0 and sine of 0 is also 0. So we will have cos of 1 upon 4 pi, which is root 2 upon 2, and this will be pi only, so that we will have pi with a negative sign, plus 4 sine of half 1 upon 4 pi, that is also root 2 upon 2. This will cancel out, so the final answer will be negative root 2 pi upon 2 plus 2 root 2. Now we can leave our answer in this form, or it can be given in different forms. So let's say if we take the LCM, we will have minus root 2 pi plus 4 root 2 upon 2. Taking root 2 common, we'll get 4 minus pi upon 2. We can also leave our answer in this form, or we can multiply and divide by root 2 to simplify the numerator. We get, so multiplying by root 2, we'll get 2 into 4 minus pi upon 2 root 2. This will cancel out, and we can write the final answer is also as 4 minus pi upon root 2, which is also the answer given in the mark scheme. But we could have given the answer in any of these forms, it would have been marked correct. In question 5, a curve has the equation y equals to 2 upon 3 ln of 1 plus 3 cos square x. In part 1, we have to express dy dx in terms of x. So we have y is equals to 2 upon 3 ln of 1 plus 3 cos squared of x. Now to differentiate the ln function, we know that if it is ln f of x, any function, it is written as f of x is in the denominator and the derivative of f of x is in the numerator. So we will get 1 plus 3 cos squared of x in the numerator, in the denominator, and the derivative of 1 plus 3 cos squared will become, so the derivative of 3 cos squared will be 2 times 3 will become 6 cos, and the derivative of cos is minus sine. So that will become minus 6 cos sine. We'll cancel this and this will become y is equals to minus 4 sine cos upon 1 plus 3 cos squared. Now we have to give the dy dx. So we have already found out the dy dx. Now we have to give this in terms of tan x. Now what we must remember is that we'll have, as we are converting this particular equation into in terms of tan x, we cannot introduce any identity to bring tan. So we'll have to use an algebraic method. Now to get a tan in the numerator, we need sine upon cos, but we have a cos over here. So let's say if we divide 4 sine cos by, so if we just divide by cos, cos and cos will cancel out. But if we divide by cos squared, this will cancel and we'll have sine upon cos, which will eventually convert to tan. And then doing the same in the denominator as well, dividing it by cos squared on both the sides. So we know that 1 upon cos squared is sec squared, and the identity for sec squared of x is 1 plus tan squared. So we'll get minus 4 sine upon cos, which can be written as minus 4 tan of x upon 1 upon cos squared is sec squared of x, and in place of sec squared, now we can write 1 plus tan squared. So that will become 1 plus tan squared of x, and this is plus 3. So for the final answer in terms of tan will be dy dx will be is equals to minus 4 tan x upon 1 plus 3, 4. So that will become 4 plus tan squared of x. In part 2, it says, hence find the x coordinate of the point on which the gradient is 1, giving our answer to 3 significant figures. Now we know that the dy dx will be taken as 1. So we in minus 1, so in place of dy dx, we can write minus 1 is equals to minus 4 tan upon 4 plus tan squared. Cross multiplying, we'll get minus 4 minus tan squared is equals to minus 4 tan. So we can just change the sign and this equation will become as, so this will become tan squared plus 4 tan, and so this was minus 4 tan upon 4 plus tan, multiplying it with minus 1. Okay, so this would have become 4 plus tan, and when we bring the 4 tan on the right hand side to the left hand side, this will become tan squared plus 4 tan plus 4 equals to 0. Factorizing this, we'll get tan plus 2 whole squared is equals to 0. So tan x will be is equals to minus 2. Taking tan inverse of minus 2 in the calculator, we'll get x is equals to minus 1.107. And as we have to give our answer to 3 significant figures, so the final answer will be minus 1.11.
In question 6, it says that the equation cot x equals to 1 minus x has one root in the interval denoted by alpha. We have to show by calculation that alpha is greater than 2.5. Now, what this means is, let's say if I draw an x-axis and the root is greater than 2.5, so let's say if this is 2.5 over here, so the root would be, let's say it could be, the curve could be going upwards, it could be going downwards. In any case, what we'll see is that when we put 2.5, it will have a negative or a positive value. And if we place a value greater than 2.5, there will be a change of sign, which will show that the root will be greater than 2.5, but lesser than that particular value. So we'll start off by arranging it as cot x minus 1 plus x is equals to 0, as the value of x that gives a root basically will turn the whole equation equals to 0. So starting off with writing cot x as 1 upon tan x minus 1 plus x is equals to 0. Now we'll substitute the values in the calculator. So let's say first making sure our calculator is set to radian mode, and then doing 1 divided by tan of 2.5 minus 1 plus 2.5. So the value I'm getting is the value of x in this case is, or the answer I'm getting is 0.16135. Now this is a positive value. Now let's take a larger value as alpha is between 2.0 and pi, which is basically 3.142. So let's take a value which we can take pi as well. So let's say 1 divided by tan of pi, but tan of pi that's infinity. So let's take 3. Instead of 3.142, let's take 3. So this will become 1 divided by tan of 3. So I'm taking 1 upon tan of 3 minus 1 plus 3. So 1 divided by tan 3 minus 1 plus 3. We are getting our answer as minus 5.015. Now this change of sign basically from positive to negative shows that the root is between 2.5 and 3. So it is greater than 2.5. And that's what we had to show. Now in part 2, it says that show that if a sequence of values in the interval is given by the iterative formula, then it converges to alpha. So to show that it converges to alpha, we have to show that this equation can be written in this form. So let's first remove this n plus 1, and we can write it as x is equals to pi plus tan inverse of 1 upon 1 minus x. So we can write it as x minus pi over here, which is equals to tan inverse of 1 upon 1 minus x. And then using the basics, let's say if tan y is equals to x, we say y is tan inverse of x. So we can write it both ways, which means if tan of x, tan inverse of x is y, so we can say, let's say this whole thing is x and this whole thing is y. We can write this equation as tan of x minus pi is equals to 1 upon 1 minus x. So that's the first step. Now, in the question, what we had was cot x is equals to 1 minus x. Now, what we know is that tan is, so tan x is equals to 1 upon cot x. So we can write it as 1 upon cot of x minus pi is equals to 1 upon 1 minus x. So we can say cot of x minus pi is equals to 1 minus x. Now cot of x minus pi and cot of x will give us the same values, and we can check it from the calculator as well. So we can write it as cot of x is equals to 1 minus x, as this is the same as cot of x. In part 3, it says use the iterative formula to determine alpha correct to 3 decimal place. So to find the value of alpha, we know that the value lies between 2.5 and 3 from the first part. So the equation is x is equals to pi plus tan inverse of 1 upon 1 minus x. Now we can start off with any initial value between 2.5 and 3, or we can just start directly with 2.5 as well. So we can write it as pi plus tan inverse of 1 upon 1 minus, and the initial value of x that we will take is x is equals to, so the initial value 0 is 2.5. Substituting this in the calculator, we'll get tan inverse of 1 divided by 1 minus 2.5. So 1 divided by 1 minus 2.5, and then pi plus the answer. So shift pi plus tan inverse of 1 divided by 1 minus 2.5 is minus 1.5. So we can write it as minus 1.5. and the answer is 2.55. So we'll write it as 2.5, and we have to give the result of each iteration to 5 decimal. So this will be 2.55359. Now we will have to make sure that we substitute exactly this value in a calculator to find the next value. So to find the next value, it will become pi plus tan inverse of 1 upon 1 minus, and we'll substitute this whole value. I will not write the whole thing, but in the calculator, I will substitute the whole thing. Well, I've written it over here anyways. So this will become 1 minus 2.55395, 1 divided by answer, and then shift tan inverse of answer. And then we add pi to the final answer. And we are getting 2.569785. So this should be 2.5697, and this will become 9. And now using the same value to find the next value, so we'll get 1 divided by 1 minus 2.56979, tan inverse of answer, and then we again add pi to the answer, and now we are getting 2.57439. And then the next value will be 1 minus this answer, then we divide by 1, and then shift tan inverse, and then adding pi to it, we are getting 2.575716. So in place of 1, we can write 2 over here. And then for the next value, we'll again subtract it from 1, then divide by 1, take tan inverse of the answer, and then add pi to the final answer. You're getting 2.57609. And now we can see that we are finally getting our values nearly same to the third decimal place as well. So let's try it one more time. The sixth value will be, so 1 minus this answer, 1 divide by the answer, taking tan inverse, and then adding pi over here. You're getting 2.576 again, 57620. And if we substitute this again over here, we'll still get 2.576. So as we have to give our answer correct to 3 decimal place, we can say that x will be is equals to 2.576. In question 7, it says that the diagram shows a sketch of the curve y equals e power half x upon x and its minimum point m. We have to find the x coordinate of m. Now, as it's a minimum point, it means that dy dx, or the gradient, will be equals to 0. So in the first step, we'll just write dy dx, and as the two terms are dividing, we will be applying the quotient rule. So that is vu dash minus uv dash divided by v squared. Now, in our question, u is e power half x, as is in the numerator, and v is equals to x. So the derivative of u, or u dash, will become e power half x divided by half. So when we divide by half, we can also multiply by 2, and the derivative of x will be 1. Now substituting these values in the formula, we will get, so v times u dash will become 2x e power half x minus uv dash will become e power half x divided by v squared. So v squared will be x whole squared, and we'll put this as equals to 0, as it says it is a minimum point. Now, when we cross multiply, this will cancel out. X squared times 0 will be 0. And then we bring e power half x on the left hand side. So we'll get 2x e power half x is equals to e power half x. So e power half x and e power half x will cancel on both the sides. So then the value of x will be is equals to 1 over 2. In question 7, the diagram shows a sketch of the curve y equals e power half x upon x for x greater than 0 and the minimum point m. In the first part, we have to find the x coordinate of m. Now, as it's a minimum point, we know that dy dx will be equal to 0, and dy dx will be given as, we'll apply the quotient rule, that is vu dash minus uv dash divided by v squared. So in our question, u is in the new e power half x is in the numerator, so that will be taken as u, and the derivative of u will be, so the derivative of half x is half, so this will become half e power half x. V will be is equals to x, so v dash will be is equals to 1. Substituting this in the formula, we will get x multiplied by half, so half x e power half x minus uv dash will become e power half x divided by v squared. So v squared will become x squared, and we'll put it equals to 0 as it's a minimum point. Cross multiplying x squared into 0, that will become 0. And then we'll take e power half x on the left hand side. So that will be is equals to e power half x is equals to half x e power half x. This will cancel out. We'll get half x is equals to 2. Half x equals to 1. So we'll have 1 remaining on the left hand side. So the value of x will be equals to 2. In part 2, we have trapezium rule, but that is not part of the syllabus. So we can just ignore this part and we can move on. In question 8, it says that in a certain chemical reaction, a compound A is formed from a compound B. The masses of A and B are given as X and Y, and the sum of the masses is equals to 50 throughout the reaction. So initially, we can simply write that X plus Y is equals to 50. It says at any time that the rate of increase of mass A, so when we talk about the rate of increase, we write it as dx by dt is proportional to, so we make the proportional sign, is proportional to the mass of B, which is equals to Y. We have to explain why dx by dt is equals to k into 50 minus x. So we can write this as dx upon dt is equals to ky. And as we have to give it in terms of x, we know from our first equation that y equals to 50 minus x. So in place of y, now we can write dx by dt is equals to k into 50 minus x. In part 2, it says we have to solve the differential equation, and we have been given some values of x and t. Now to solve a differential equation, we'll bring the variable x with dx. So we can write it as dx upon 50 minus x is equals to k dt. And the next step will be to integrate both the sides. So this will become, when we integrate 1 upon 50 minus x, we can first write it like this. So when we integrate 1 upon 50 minus x, that will become ln of 50 minus x, and we'll put a negative sign as that is the derivative of 50 minus x, which is minus 1, will be is equals to kt plus c. Now we have two unknowns over two constants that are unknown, that is k and c. We know initial value of x is 0 when t is 0. So in place of x, we can write 0, that we'll get minus ln 50 is equals to 0 plus c. So c is equals to minus ln of 50. To find the value of k, we can now substitute x equals to 25, t equals to 10, and we already have the value of c. So in the same equation, we'll write it as now minus ln of, and we can again take x as 0 and t as 0 as well to find the, but we can't take t0 as this will become 0 as well. So we'll have to take x25 and t10. So 50 minus 25, that will become 25 is equals to 10k minus ln of 50. Bringing this on the left hand side, we'll get 10k is equals to ln of 50 minus ln of 25. Applying the basic rules of logarithms, this will become 50 upon 25. So 10k is equals to ln of 2, and k will be is equals to ln 2 upon 10. Now once we have the values of k and c, we have to express x in terms of t, meaning we just have to make x our subject. So we'll just first write down the equation minus ln of 50 minus x is equals to kt. K is ln 2 upon 10 plus c, and the value of c is minus ln of 50. Now to make x the subject, what we can do is first on the left hand side, we can bring all the ln terms together. So we can also write it as ln of 50 minus x minus ln of 2 upon 10 and plus ln of 50. Now we can first take the LCM. So this will become minus 10 ln of 50 minus x, and this will be equals to 0. Minus ln of 2 plus 10 ln of 50 is equals to, and as 10 is a common denominator, it will multiply by 0 to make the whole thing on the right hand side equals to 0. Now applying the basic laws of logarithms, we can also write this as, so we can bring the minus 10 power over here. So this will become minus 10 minus ln of 2 plus ln of 50. However, this becomes too complicated. So what we can do is, in the first step, we can just bring ln of 50 minus x and ln of 50 on one side. So we can write it as minus ln of 50 minus x plus ln of 50 is equals to ln of 2 upon 10. Now applying the rules of logarithms, we'll write it as 50 upon 50 minus x is equals to ln of 2 upon 10. And now what we know is that if it is ln of y is equals to x, so y is equals to e to the power of x. So we can write this as 50 upon 50 minus x is equals to e to the power ln of 2 upon 10. Now cross multiplying, as we have to make x the subject, that becomes 50 is equals to 50 e power ln 2 upon 10 minus x e power ln of 2 upon 10. Bringing this on the left hand side to make it positive, we'll get x e power ln of 2 upon 10 is equals to 50 e ln of 2 upon 10 minus 50. Finally, making x our subject, we'll get x is equals to 50 e power ln of 2 upon 10 minus 50, and both of these terms will divide by e to the power ln of 2 upon 10, and this will also divide by e to the power ln of 2 upon 10. So this will cancel out on both the sides, and finally we can give our answer as 50 minus 50, and we can bring this in the numerator and write it as e to the power minus ln of 2 upon 10. And that will be the final answer for x in terms of t. Just one small correction over here. This was supposed to be, this was kt, so we had to mention a t over here. So this will be t over here as well, over here as well, and then over here as well. So nothing changes in our answer except the fact that we will have this as e to the power t ln of uh, ln of 2 upon 10. So if we cross multiply, this will be, this will have a t over here, this will have a t over here as well. And when we divide it, so this will also have t over here, and this will also have a t over here. So this will cancel out and we'll have t over here. So we just correct it and write our answer as 50 minus 50 e to the power minus t ln of 2 upon 10. And this will be the final answer. In question number 9, its function is given as 3x squared minus 4 upon x squared into 3x plus 2. In the first part, we have to express f of x as partial fractions. Now in the denominator, we have x squared. So what we know is that if it is x squared, we can write it as a upon x plus b upon x squared. Now the reason for this is that whenever, let's say in the denominator, if we have 3 and 9, the LCM will always come out as the square of the number. So the two possible fractions will be the number and its square. And we can do this with any number. So let's say there was 2 or 4 in the denominator, the LCM will be 4. If you had 4 and 16, the LCM would be 16, and so on and so forth. So we'll get x and x square, and we also have 3x plus 2, so we can write it as plus c upon 3x plus 2, and that will be equals to our function 3x square minus 4 divided by x square into 3x plus 2. Now applying LCM, so a in the denominator, a has x only, so we'll multiply a with x and 3x plus 2, b has x square in the denominator so already, so we'll just multiply b by 3x plus 2, and c will multiply by x squared. And now we'll compare it with the numerator, which is 3x square minus 4. Now there are multiple ways we can approach this to find the values of a, b, and c. We can expand the right hand side and then compare with the left hand side, or we can assume values of x to get values of a, b, and c. So in the first instance, we can, let's say if we take x is equals to 0, so the a and c terms will cancel out. So when the a and c terms cancel out, we will get 3 into 0 is 0 minus 4 is equals to 0 plus b into 3 times 0 will be 0 as well. So that will become b into 2 plus 0. So 2b is equals to minus 4, b will be equals to minus 2. Now, if we take x equals to minus 2 upon 3, we'll we'll be able to cancel out a and b as well. So taking x is equals to minus 2 upon 3, and what we can always do is we can just put it equals to 0. So x will be minus 2 upon 3. So in that way, we'll be able to cancel out two more terms. So in place of x, now we'll substitute minus 2 upon 3 minus 4. A and b terms become 0. So we'll just multiply c by minus 2 upon 3 whole squared. So this will become 3 into 4 upon 9 minus 4 is equals to c into 4 upon 9. The first step will simplify the left hand side. So this is 4 upon 3 minus 4. So that will become 4 minus 12 upon 3. So 4 minus 12, that is minus 8 upon 3 is equals to 4c upon 9. Now, if we cross multiply, but we can simply cancel out like this as well. So c 1 times, 4 1 times, and 4 2 times, 3 1 times, and 3 times. 3 times 2 is 6. So the value of c will be equals to minus 6. And finally, to find the value of a or the remaining constant, we can assume any value of x. So if we, let's say, take x equals to 1 and put it throughout the whole equation, we'll get 3 minus 4, which is equals to minus 1 equals to. So we already, so a will be a into 1 into 3 times 1 plus 2, that will become 5 plus b. So b value we already have as minus 2. So we can write minus 2 into 3 1 times 3 plus 2, that becomes 5 again, and plus cx square. So cx square will become minus c is 6 minus 6, and x square, which is 1 square, that will be 1. So we'll get minus 1 is equals to 5a minus 10 minus 16. This will become minus 1 plus 10 plus 16 equals to 5a. So the value of a will be, so minus 1 plus 10 is 9, 9 plus 16 is 25 is equals to 5a, and the value of a will be equals to 5. So now we have our the values for the numerators, and we can write our answer as a upon x. So that will become 5 upon x. B value is minus 2. So minus 2 upon x squared, and minus 6 upon 3x plus 2. Now in the next part, we have to show that the integral of f of x is equals to ln of 25 upon 8 minus 1, and the limits are given as 2 and 1. So we already have the function in partial fraction form. So we'll just have to integrate 5 upon x minus 2 upon x squared minus 6 upon 3x plus 2. Now integrating 5 upon x, we will get 5 ln of x. To integrate 2 upon x squared, so let's keep it as 2 upon x squared. X squared goes in the numerator. We add one power, divide by the new power. So we'll get, and we get getting a negative sign again. So negative negative will make it positive over here. So we'll get plus 2x to the power of minus 1, and then minus 6 ln of 3x plus 2, and the derivative of 3x plus 2, which is 3, goes into the denominator. We divide it by 3. So this will become 2. So we can write our answer as 5 ln of x plus 2 upon x, and then minus 2 ln of 3x plus 2. Substituting the limits now, The upper limit is 2, so we'll get 5 ln of 2 plus 2 upon 2 is 1 minus 2 ln of 3 times 2 is 6, 6 plus 2 is 8. And now substituting the lower limit, that is 1, so we'll get 5 ln 1 plus 2 upon 1 minus 2 ln of, so 3 1 times 3 plus 2 is 5. All right. Now, once we have this and we have to give this as ln of 25 upon 8, first we can write 5 ln 2 is ln of 2 power 5 plus 1 minus ln 8 to the power of 2. Ln 1 is 0, so we can ignore that. And this will be 2 minus ln of 5 to the power of 2. Simplifying this, now ln 2 to the power 5, so to the power 5 is 32. And we can now put the ln terms together. So this will be minus ln of 64. This will become minus minus plus. So that will become plus ln of 25. And 1 minus 2 will be minus 1. And now simplifying this. So this is dividing over here, and ln 32 and 25 are positive. So we can write it as ln of 32 into 25 divided by 64 minus 1. And so this will become 32 one times, 32 two times. And over here it is ln 25 over 8. So we'll just have to check for our mistake over here. Okay, so the mistake I found out was that over here this was a 6, and I wrote it as 16 over here. So that made this partial fraction part wrong. So again, I'm writing 16. Let's write 6 over here. And now when I write 6 over here, this will become minus 9 plus 16 is 9 plus 6 is 15. So the value of A will be 3. Now, so when as that is 3, so I'll have to write 3 over here as well. So this will become 3, this is 3, and this is 3. Similarly, we have to correct all of this as well. So this will become 3, and this will also become 3. So this is 2 to the power 5, with instead this will become 2 to the power of 3, which is equals to 8. And now instead in the denominator of 64, we will, so yeah, this will become 8 into, so this will be 8 multiplied by 25 divided by 64. And we had to get ln 25 upon 8. So this will become 8 ones are 8 eights are. So we are finally able to prove that the integral will be ln of 25 over 8 minus 1. In question 10, it says that the points A and B have position vectors. The line has equation 2i plus j plus mk plus mu, where m is a constant. We have to it says that given that line L intersects the line passing through A and B, we have to find the value of m. Now the first step will be to make an equation for the line passing through A and B. So in the first step, we'll find the direction vector for AB, that is B minus A. So this will be is equals to, so this is I minus 2, B is 3. So that is 3I plus J plus K. And then we subtract it from I minus 2J plus 2K. So 3I minus I, that will become 2I. J, and this will become minus minus plus, so that will become plus 3J. And K minus 2K will become minus K. So this is the direction vector. To find the equation of the line, let's say we can say the line is R1. So it is given as a point on the line. We write it as A plus lambda T or mu, whatever we want to use. And where we can say T is the direction and A is any point on the line. So we can use a point A, which is 1 minus 2 and 2 plus lambda, and the direction vector will be 2, 3, and minus 1. So now we have the line that is passing through A and B, the equation of this line. Now, as they are intersecting, what we'll simply do is we'll write this in parametric form. This will become 1 plus 2 lambda. This is already in parametric form. and this will become 2 minus lambda. And the equation of line R was that we can write it as 2i plus mu into 1 will be mu, so 2 plus mu. This is j into j minus 2 mu, so this will become 1 minus 2 mu, and this is mk, so we'll write it as m, and minus 4 times mu will become minus 4 mu. So as they're intersecting, the x, y, and z values should be equal. So we can first find the value of mu and lambda, mu using x and y values. As m is unknown over here, so we can use the x and y values to find the value of mu. So we can say that as they're intersecting, the x values will be equal. So 2 plus mu will be equals to 1 plus 2 lambda, and 1 minus 2 mu will be is equals to minus 2 plus 3 lambda. Simplifying this, we'll get mu minus 2 lambda is equals to minus 1. This will become minus 2 mu minus 3 lambda is equals to minus 2 minus 1 will become minus 3. Solving this simultaneously, we can just multiply this equation by 2. We'll get minus 2 mu minus 4 lambda is equals to minus 2. This will be positive 2. So यहाँ पे we'll have positive 2 mu as we are multiplying this equation. Yeah, so you're multiplying the first equation by 2, you'll get 2 mu minus 4 lambda minus 2. This will cancel out. Minus 3 minus 4 is minus 7 lambda, and that is equals to minus 3 minus 2 is minus 5. So lambda is 5 upon 7. And once we have lambda, we can find the value of mu. So this will become, so minus 2 mu will be is equals to minus 3 plus 15 upon 7. That is minus 2 mu is equals to minus 3. So this is minus 21. Minus 21 plus 15 is minus 6 upon 7. Minus minus cancels. So the value of mu will be, we can cancel it out and write it as 3 upon 7. Now, as they're intersecting, so the z value should also be the same. So first we'll write 2 minus lambda. So that will become 2 minus 5 upon 7. So that will be 14 minus 5. That is 9 upon 7. So it means m minus 4 mu should also be 9 upon 7. So m minus 4 mu is equals to 9 upon 7. We have the value of mu, which is 3 upon 7 over here. So m will be is equals to 9 upon 7 plus 12 upon 7. 12 plus 9 is 21. So we can write it as 21 upon 7. And the final answer for m will be m is equals to 3. In part B, it is asking us to find the equation of the plane, but that is not part of the syllabus anymore. So we can just stop over here because that's all there is in the syllabus for vectors.